Problem 1. Let R be the region bounded by the graphs of y equals sine of pi x and y equals x cubed minus 4x, shown in the figure above. Part A, find the area of R. Okay, to find the area, we're simply going to go where they intersect, 0 to 2, and then it's just going to be top minus bottom. I can tell the top is the curve sine of pi x minus the bottom would be x cubed minus 4x. Biggest thing on that one, make sure that you do put the x cubed minus 4x in parentheses. And when you do that, this is a calculator problem, so you can figure that out and your answer will be 4. That problem fortunately was worth 3 points. We got 1 point if you have the limits going from 0 to 2, 1 point for the correct integrand setup, and then 1 point for your answer. Please remember that if you would have gotten a negative, you know you have your top and your bottom mixed up, and just change them. Okay, part B, the horizontal line y equals -2 splits the region into 2 parts. Write, but do not evaluate, an integral expression for the area of the part of R that is below the horizontal line. So I'm going to make the horizontal line y equals -2 right here. So this time they're just asking us to find this area. So we're going to set it up just like we did on part A, but this time notice it's not going to go to 0 to 2, it's going to go for where those two intersect. So I would, and it's going to be where -2 intersects x cubed minus 4x. So if I use intersect on that one, I can find the points of intersection. And so if I do that, I will be going from 0.53919, and up top I will be going 1.67513. And then my top this time will be the line -2, and my bottom will still be x cubed minus 4x, and again I have to have it in parentheses, and the whole thing is dx. So this was worth 2 points if you had your limits correct, and you remember your limits have to go correct to 3 places, but it's nice to have them go more than that, and then 1 point if you have the proper integrand. All right. Part C, the region R is the base of a solid. For this solid, each cross-section perpendicular to the y-axis is a square. Find the volume of the solid. Well, we know that if we're going to get a volume, it's just going to be the integral of the area. And in this case, the area is a square, which is side squared. And in this case, we will do top minus bottom because we're perpendicular to the x-axis to get the side. So the top will be sine of pi x minus the bottom, again in parentheses, will be x cubed minus 4x, and then we're going to square that entire quantity. So our volume will equal the integral. Again, it's the whole entire region R, so we'll go from 0 to 2, and it will be sine of pi x minus x cubed minus 4x quantity squared. And this one actually said to find the volume, and if I find the volume, if I use Math 9 on my calculator, I should get a value of 9.978. And this problem was worth 2 points. You got 1 point if you have the inside right. So if you have this, give yourself a point. And then if you have the right answer, give yourself a point. All right, part D, the region R models the surface of a small pond. At all points in R at a distance x from the y-axis, the depth of the water is given by h of x equals 3 minus x. Find the volume of the water in the pond. All right, well, to get volume, I know I'm just going to take the area and I'm going to multiply it by the height. So I'm basically going to take what I was doing in my area problem. I know that this is going to be going from 0 to 2. The area, remember the setup, we did top minus bottom, so it'll be the sine of pi x minus x cubed minus 4x, again in parentheses. And then from here, we're going to take this and we're going to multiply it by the height, which was 3 minus x. Okay, so that goes inside, and the reason that the 3 minus x goes on the inside is because the x is changing, so we do want it to go from 0 to 2, just like the other ones. And then from here, we can use Math 9 to evaluate that, and we should get 8.369 or 8.370 would also be acceptable. All right, that was worth 2 points. If you have the correct inside setup, give yourself a point. And then if you have the correct answer, give yourself a point. So if you didn't have the correct inside setup, then you can't get the right point for the answer. So hopefully this was a good problem for you.